Hello, welcome back to the channel. In this video, I am going to discuss Cambridge International AS Physics Paper 1, May June 2024, Paper 1-2. Are you ready? Let us get started. Now, let us look at the first question. What is a scalar quantity? Now, you have to know that physical quantity can be divided into two big groups. One is called scalar quantity. The other one is called vector quantity. Scalar quantity is a quantity that has only magnitude, the value, together with the appropriate units. Whereas a vector quantity is the quantity that consists of both magnitude, the value, with the appropriate units, as well as the direction. For example, scalar quantity. I run with 200 meter per second. You can say full stop. And you can say, wow, this person runs so fast. Okay, their situation is that I tell you, I run with 200 meter per second eastwards. You will be like, where's this person going? This person runs so fast. Could you see that I give you so many information, right? Vector quantity gives you more information with the added direction, right? Whereas scalar quantity, it just tells you whether I'm running fast. That's all. I don't give you any direction, right? So let us look at the answer. A, the quantity can be represented by two perpendicular directions, two perpendicular components. Two perpendicular components could be X, could be Y component. That is more like a vector quantity. So this is wrong. Be a quantity that does not require a unit. Whenever there is an appropriate unit, you have to put a unit for a scalar quantity. So this is wrong. C, a quantity without a direction. That is true. And D, a quantity without a unit. How can it be without a quantity without a magnitude? How can it be without a magnitude? That is wrong. Therefore, the answer is C. Question number 2, the value of quantity X has a percentage uncertainty of 2%. The value of quantity Y has a percentage uncertainty of 4%. The value of quantity W is calculated from the values of X and Y. The value of W has a percentage uncertainty of 8%. What could be the relationship between W, X, and Y? Now, I'm going to do that one by one. Let us look at A. This is about multiplication. So you add the percentage uncertainty. So for A, it is percentage uncertainty of W is equal to percentage uncertainty of X times 100% plus the percentage uncertainty of Y times 100%. So percentage uncertainty of X is 2%, Y is 4%, W is supposed to end up with 6%. But the question told you that W is supposed to be 8%. A cannot be your answer. Let us look at B. I'm going to do B here. Here, this is B. So W is equal to 2XY. Now, 2 is just a number. You can just ignore it. So this is about multiplication. So delta W over W times 100% is equal to delta X over X times 100% plus delta Y over Y times 100%. Delta X is 2%, delta Y is 4%. Again, for delta W, the percentage uncertainty of delta W, the percentage uncertainty of W is supposed to end up with 6%. So B cannot be your answer as well. What about C? Let me do C. I'm going to do C right here. W is equal to X over Y squared. Now, this is a power factor. So that is why delta W over W times 100%, percentage uncertainty of W, plus equals to percentage uncertainty of X. So since this is a power factor, you just times the power to the fractional uncertainty of Y, and then you times 100%. Now, let me see. X is 2%, and then Y is 4%, 2 times 4. So 2 plus 8%. So that's supposed to give you 10% for C, but W, the percentage uncertainty of W is only 8%. C cannot be the answer. Now, I just want to prove D is the correct answer. So for D, I find the percentage uncertainty of W first equals percentage uncertainty of Y plus power factor, the power, which is a square, times the fractional uncertainty of X first before you times 100%. Delta Y over Y times 100%, that is 4%, plus 2. Delta X over X times 100% is 2%. So this is 4% plus 4%. So you end up getting 8%, which is correct. D is the answer. Question number 3. A football is kicked so that it moves vertically upwards through the air. Okay, this is my football. So football is kicked to move upwards. And there must be air resistance acting on the football. Okay, the air resistance, this is the direction of the football where it is being kicked up. Air resistance is acting downwards in this case because air resistance is a hindrance from the air particles which acting in the opposite direction to the motion of the ball. So you have to be extra careful. This is my air resistance. Oh, I better write it nicely. This is my air resistance. Air resistance is here. And of course, when the ball is kicked outwards, there must be a weight acting on the ball. Now, question asks, what is the variation in the air resistance and the resultant force acting on the ball as it moves vertically upwards? So when the ball is moving outwards, you could see that due to the air resistance which opposing the direction of the ball, so the ball will go up to a certain maximum height and stop for a moment before coming downwards again due to the pull of the gravity on the ball. I would say that the speed of the ball decreases when the ball is going outwards. Speed decreases. When the speed of the ball decreases, what happens to the air resistance? Since the air resistance depends on the speed, air resistance will have to decrease as well. Air resistance decreases. So let us look at the choices here. It is either A or B. Now, what happened to the resultant force? Resultant force, on the other hand, I put FR represents resultant force. It is the sum of all the forces that are acting on this football. In this case, the resultant force would be air resistance plus the weight. Air resistance and weight are acting in the same direction. And what happens to the air resistance? What happened to the resultant force when the air resistance is decreasing and weight is constant? Since air resistance is decreasing, whereas the weight is constant, resultant force acting on the ball will also decrease. That is why the answer is A. Question number 4. Which statement is not correct? Let us see. A. Acceleration can be determined from the gradient of velocity time graph. This is true. B, acceleration is the rate of change of velocity, which is also true. Final velocity minus initial velocity per time taken. That is called rate of change of velocity. This is true. C, displacement can be determined from the area under a velocity time graph. That is also true. D, velocity is the rate of change of distance. It is actually supposed to be displacement, not distance. Therefore, D is incorrect. Question number 5. The diagram shows a laboratory experiment in which a feather falls from rest. Oh, I better put this for fall from rest. U is equal to 0. In a long evacuated vertical tube of length L. Evacuated means there is no air. There's no air resistance acting on this feather. So the feather takes time t to fall from the top to the bottom of the tube. Top to the bottom. How far does a feather fall from the top of the tube in time t equal to 0.5 t? So the time taken to fall from top to bottom, that is t. So I would say 0.5 t somewhere here, maybe somewhere here, 0.5 t. I don't know. This is 0.5 t. I will just assume. And the information that I have is that feather start from here. U is equal to 0. Now, since the distance of the feather falling is given, which is the length of the whole tube, which is L, I am going to use this equation. S equal to UT plus half GT squared, because this is about falling feather. I replace the A with G, gravitational acceleration. Now, I would consider at falling at time t equal to 0 to t equal time t. That means from the top of the tube all the way to the bottom of the tube. Now, the distance would be L. U, it is 0 times t plus half 9.81 t squared. That is my first equation. So my L is equal to 4.905 t squared. I get one expression for that. And then after that, I'm going to consider at time equal to 0 to time equal to 0.5 t. Using back the same equation, now my distance, I don't know. I just put L new because it's definitely not half. You cannot assume it that way. L new is equal to 0 because I start from 0. Okay, t plus half g 9.81. In this case, my t square will be 0.5 t, and then the whole thing I square it. So the new L is equal to 1.226 t squared. I have the first equation and I have the second equation. Now I want to determine the new length when it has already fall, right, in time 0.5 t. So I'm going to use the second equation, simultaneous equation, divide the first equation. So this is a new L divided by L is equal to 1.226 t squared divided by 4.905 t squared. Now this t squared can be cancelled off and you get L new is equal to 0.25 L. B is the answer. Question number 6. A car travels along a straight horizontal road. The graph shows the variation of the velocity v of the car with time t equals time for 6 seconds of its journey. The brakes of the car are applied from t equal to 1 second to 4 seconds. How far does the car travel while the brakes are applied? So they have already give you from 1 second, which is here. Oh, I better have. Okay, 1 second, which is here, to 4 seconds. This is when the brakes are being applied. So they ask you how far. That means they want you to find the distance the car has already traveled when the brakes are being applied, right? Far means distance, so I have to find the distance. When a graph is being given, there are two information that you could obtain from the graph. One is the gradient of the graph. The other one is the area under the graph. The gradient of the speed time graph, VT graph, gives you acceleration. Whereas the area of the speed time graph, VT graphs, give you the distance, the total distance traveled. So I'm going to find the distance, right, which is area under graph. So how do I find the area? Okay, area of what? This is the area that I'm supposed to find. It is the area of trapezium. So I'm going to get a value here first. This value is 8. And then the value here, 20, 21, 22. So, okay, the distance is area of the trapezium. Area of trapezium is half. A plus B, 22 plus 8 times with the full length, 4 minus 1. Have to be extra careful. When you do it, you're supposed to get 45 meters. B is the answer. Question number 7. Two satellites in deep space collide inelastically. Wow, inelastically. And what happens to the total kinetic energy and total momentum? Bear in mind, for inelastic collision, total kinetic energy is not conserved because the final kinetic energy is lesser as compared to initial kinetic energy. Why? Due to inelastic collision, like for example, my calculator and my head. Some of the initial kinetic energy has been transformed to sound, light, heat, etc. So that is why the total kinetic energy is being reduced. Total momentum, on the other hand, principle of conservation of momentum must be obeyed. That is why the total momentum is always conserved. C is the answer. Question number 8. What is a reasonable estimate of a momentum of a family car? Okay, traveling at 25 kilometers per hour. I am going to state that momentum, maybe I just estimate, maybe momentum is mass times velocity. Oh, this velocity, I got to change it to meter per second. I would estimate the mass of a family car, maybe 2,000 times velocity, 25 kilometer, 25 km per hour. So kilometer is 1,000. You want to change it to meter. 1 hour, 60 minutes, 1 minute, 60 seconds. So I'm going to do it right now. 25. So I got 1.3 times 10 to the power of 4 kilogram meter per second. So 1.3 is, I round it off to 1. 1 times 10 to the power of 4 kilogram meter per second. A is the answer. So estimation is you estimate the mass of the family car. Number 9, a ball collides with a wall. Before the collision, the ball moves with a velocity 8 meters per second to the right. After the collision, it moves with velocity 3 meters per second to the left. What is the change in the velocity of the ball during the collision? Now, when I see this type of question, it's very hard for me to imagine, put everything into my small little head here. That is why I prefer to sketch. I wasn't born to be an artist, but it's just that I sketch so that I can see better. Now, this is a ball. Travels to the right with 8 meters per second. And then after the collision with the wall, too bad, it has to move back with 3 meters per second. They didn't ask about momentum, which I expected them to ask about momentum, but they asked about the change in velocity. And you have to remember, change in velocity is your final velocity minus initial velocity. And bear one more thing in mind. Velocity is a vector quantity. Therefore, direction is very important. You could see that this is my final velocity. This is my initial velocity. Look at the direction. One is towards left, the other one is towards right, right? So they are acting in opposite directions. So you have to put positive to one direction, which I put it to the left, right? Negative, I put it to the right. So I just put 3, positive 3 minus negative 8 because initial velocity is towards right. So this is 3 plus 8, which is 11 meter per second. 11 meter per second, change occur to the left. I get positive, that is why it is to the left. C is the answer because I consider to the left as positive. Now, question number 10, a lead pellet is shot vertically upwards into a clay block that is stationary at the moment of impact, but it is able to rise freely after impact. Mass of the pellet is 5 grams and the mass of the clay block is 95 grams. Pellet hits the block with an initial vertical velocity of 200 meters per second. It embeds itself in the block and does not emerge. How high above its initial position will the block rise? Okay, this is not so easy. I am going to do it in terms of I need to calculate the final velocity because I only have initial velocity of the pellet, the lead pellet. And then the question mentioned that it embeds itself in the block and does not emerge. And then how high it rise, okay, there must be a speed of rising after that. So in order for them to move together to a certain height, so this clay block and the pellet must move together. So I'm using the principle of conservation of momentum first, right? So initially the total momentum, initial momentum is equal to final momentum. So I need to calculate the speed of the pallet and the block together. So the initial momentum is related to pallet only, which is 5 gram. You have to change to kilogram, 5 times 10 to the power negative 3. And with the initial velocity, 200, which is equal to final velocity of clay block as well as the lead pallet. So this is 5 plus 95 times 10 to the power negative 3 because I want to change it to kilogram, or you can divide by 1000 final velocity. And the final velocity I got was 10 meter per second. And then do I have to use this? Oh, yeah. Okay. Now I find my energy changes, yeah, between the I am using the principle of conservation of energy after that. So since I'm going to use the principle of conservation of energy to do the calculation, because the question is a little bit tricky here. The question mentioned how high above its initial position will the block rise. So the block is initially at a certain height, but due to the fast moving lead pallet, the embedded in it makes it move a little bit higher. So how high? So I need to find the difference between the two heights, initial height and the final height. So I'm now using the principle of conservation of energy to find the initial height of the clay block, right? So our total initial energy is equal to total final energy. This is principle of conservation of energy. Total initial energy is about the kinetic energy of the lead pallet, which is being converted to final kinetic energy of the pallet together with the clay block plus the GPE, right? Gravitational potential energy. Kinetic energy is half m pallet u square, pallet square, which is equal to final kinetic energy is half m pallet plus m block v square plus mgh, m pallet plus m block g times the initial height of the block. So half mass pallet is 5 gram. You have to change it to kilogram. 200, you have to square it. Half 95 plus 5. And then you have to change it to kilogram as well. And the final velocity is 10. You see the one that I got just now, 10 square plus mass of the pallet plus the mass of the block. And then times G, which is 9.81, and then initial height of the block. And when you work it out, the initial height of the block is equal to, let me, simplify this a little bit. Here on the left-hand side, you are supposed to get 100. On the right-hand side, this one is supposed to be 5 plus 0.981 H. So the H is equal to 96.84 meter. It doesn't matter how many significant figures that I put in because this is definitely not my final answer yet. And after that, I'm going to use the same principle of conservation of energy to find the final height of the clay block. So I'm going to use initial energy is equal to final energy. So the initial energy is equal to the kinetic energy of the pallet is equal to final energy, which is a GPE of both the clay block and pallet. So half m pallet u pallet square is equal to m pallet plus m block G and H final. So half 5 times 10 to the power negative 3. This is 200 square is equal to 5 plus 95, 10 to the power negative 3 because I want to convert it to kilogram. G is 9.81 and find the final height. So you should get final height as 101.94 meter. So how high above the initial position? That is your delta H. 101.94 minus 96.84 meter, you are supposed to get 5.1 meter. A is the answer. Quite complicated, huh? Question number 11. For question number 10, if you have a shortcut to lead you to the answer, you can also share your comment below. So you can share your thought, just comment below. Thank you very much. Number 11, two forces act on an object. Which diagram represents a couple? So what is a couple? You know, not only humans, not only living things need couple, right? Even non-living thing like force also need couple. Weird, right? So couple, two forces. These two forces must be separated by a certain distance. These two forces must be of the same value, same magnitude, and they need to act in the opposite direction. That is called couple. See, 6 Newton and 6 Newton, same magnitude, and they're being separated by a distance. And one is acting upwards, the other one is acting downwards, right? That is called couple. B is the answer. Question number 12. The diagram shows a uniform rod X, Y that is freely hinged to a vertical wall at end Y. The rod is at an angle of 60 degrees to the wall. A force F acts at an angle of 30 degrees to the rod at end X. The rod has a weight of 3 Newton and is in equilibrium. What is the magnitude of force F? I'm definitely going to use moment to solve this because there's a hint, H-I-N-T given, which is a hinge here, right? So there are two forces here. One is 3 Newton, the other one is F, right? So moment, remember, the definition of moment is the force multiplies by perpendicular distance from the hinge or from the pivot, right? So I would say the length of rod XY is L. That is why the weight, because I can say that this is a uniform rod, uniform, meaning to say that the weight of this rod must act at the center of the whole length of the rod. So this will be L over 2. But hey, this is L over 2. I need to find my perpendicular distance, don't you think so? Now, this weight is acting vertically downward, so I need to find a perpendicular distance for the weight, which is here. This is the perpendicular distance of the weight. I put it as D. Right, so I'm going to use this D. So I'm going to use this triangle. I'm going to use a different highlighter to show you the triangle that I'll be using to find my D. So this is a right angle triangle that I'll be using. This is a 90 degrees. To find D, I use sine 60. So sine 60 is equal to D over L over 2. That is why perpendicular distance from 3 Newton towards a hinge is L over 2 sine 60. I got one. Whereas for the force, I need to find, okay, I need to resolve it into vertical direction here. Okay, like this. Let me erase it. Vertical direction for this force and vertical direction to the rod, 90 degrees here. Right, so I'm going to use force is right here like this. And then I just need to, okay, this is 30 degree. This is vertical direction of the force. This is 30 degrees. Yeah, this is the one. Vertical direction of the force. This is 30 degrees. And then this is F. So I'm going to use opposite. So I'm going to use sine 30 is equal to FV means vertical direction of the force over F. So F is equal to FV sine 30. So this is sorry, not FV. This is F vertical is equal to F sine 30. So F sine 30 is here, and then perpendicular distance will be the length of XY. So this is acting in this direction towards the pivot. This is clockwise direction. And weight towards the hinge. This is anti-clockwise direction. Now I can use the principle of moment. Clockwise moment is equal to anti-clockwise moment to solve that? My clockwise moment will be force F sine 30 times the whole length of x and y, which is L, equal to anti-clockwise moment, which is 3 times the perpendicular distance, L over 2 sine 60. Now, L and L can be cancelled off. Work it up. Your F supposed to be equal to 2.598 Newton, which you rounded off to 2.6 Newton. C is the answer. Question number 13. I think I will use the space below here to do question number 13. Water has a density. This is density of water, which is 1 gram per cm cube. Glycerin has a density of 1.3 g rho g. That is glycerin, which is 1.3 gram per cm cube. A student measures out a volume of 40 cm cube of glycerin. This is volume of glycerin into a container. The student adds water to the container to make a mixture of water and glycerin. Assume that the total volume of the water and the glycerin does not change when the two liquids are mixed. Which volume of water needs to be added to make a mixture of density 1.1 gram per cm cube? This is a total density. It has to be 1.1 gram per cm cube. So I'm going to tell you that it is kind of like complicated here, but I'm going to do it still. Question number 13. I am firstly going to use the mass to do it first, because I have to find, the question asked me to find the oh, it is just the volume of water that needed to add to. So since I cannot add the total density, which is equal to density of water plus density of the glycerin, because 1 plus 1.3 is definitely more than 1.1. Do you think so? I'm going to use the total mass first to find my total mass, because the total density depends on mass and volume, right? So the total density would be the total mass divided by the total volume. So total mass is the mass of the glycerin plus the mass of water. And then I know that density is equal to mass over volume. Here, I replace. Total mass would be the total density plus the total volume, equals to mass of the glycerin will be density of the glycerin, volume of the glycerin, plus density of water, plus the times volume of water. Done with that. And then, okay, remember they told us that the total volume of the water and the glycerin does not change when the two liquids are mixed, right? So I know that the total volume, which is total volume, is equal to volume of the water plus the volume of the glycerin. Therefore, the total volume is equal to volume of the water plus glycerin is 40. I just add 40. Now, okay, I replace the density first. Total density must be 1.1. Total volume, I have an expression here. Volume of the water plus 40. Volume of the water plus 40 cm cube. I do not need to change to meter cube because all the choices are in cm cube. Okay, equal to the density of the glycerin, which is equal to 1.3. And the volume of glycerin is also given, which is 40, plus density of water, which is 1, and the volume of water. Now work it out. So 1.1 volume of water plus 44 is equal to 1.3 times 40, that is 52, plus volume of water. So you put volume of water together, and then you take 52 minus 44, volume of water that you are supposed to get is 80 cm cube. 80 cm cube, D is the answer. Now, question number 14. The force resisting the motion of a car is proportional to the square of the car's speed. So I say force resisting F, or FR, resisting force. Okay, better put small r here. FR is the resisting force. Number 14, I'm going to do it here. Resisting force is directly proportional to the square of the car speed. Magnitude of the force at a speed of 20 meters per second is 800 Newton. What useful output power is required from the car's engine to maintain a steady speed? Steady speed means constant speed of 40 meters per second. Now, okay, to get rid of this proportionality, I put equal to a constant, just put a v squared there. Now I sub in for 800 Newton resistive force is equal to K. This is 20 squared. I put it as my first equation. And then now I have to find the output force first, the other force when the speed is 40 meter per second. So equal to K 40 squared. Work it out for the force first. I use the second equation, divide by the first equation. F over 800 is equal to K 40 squared divided by K 20 squared. Now, F that I got is 3,200 Newton. But this is force. Remember, it is not power. To find power, output power is equal to the force times the speed, the steady speed. So 3200 times the steady speed, which is 40, you should end up getting 128,000 watt, which is C. 128 kilowatt is the answer. Question number 15. A box of weight W is pulled by a force P along a slope. The length of the slope is D and the box rises a height H. Frictional force between the box and the slope is F. Diagram shows the direction of the forces. The purpose of the slope is to raise the box vertically. Which expression gives the efficiency of the slope? Bear in mind, efficiency can be calculated from this ratio. It is the output work or the useful output work divided by the input work. So the output work would be, because the purpose of the slope is to raise the box vertically. So I say it is GPE, and this is my input work. GPE is mgh. Mg is W, H is just H, over the input work, right? So the box is being pulled by a force P. Input is P, right? Times the distance moved by the box. Bear in mind, to find the work, the force and the distance must act in the same direction, which is D. WH over PD. D is the answer. Number 16, the kinetic energy of a particle is increased by a factor of 4. By what factor does its speed increases? So I would say that kinetic energy is equal to half mv squared. And if you don't want to use a shortcut to do it, I will use a long way to do it. So this is a general equation of the kinetic energy. I'll just put first equation. Now the kinetic energy is increased by a factor of 4. So 4 times the kinetic energy. I have to find my new speed here. So use the equation to solve it. Simultaneous equation, second equation divided by first equation. 4 ke divided by ke is equal to half mv nu square over half mv square. So cancel half m, ke, and ke. So I have here 4v square is equal to nu v square. Therefore, the nu v is equal to square root of 4v square, which is equal to 2 times the v. So the speed will increase by a factor of 2. Number 17, a mass of 28 grams is raised vertically upwards through a distance of 4.6 meters. What is the change in gravitational potential energy of the mass? Change in GPE is equal to mg, the change in height. Mass is 28 grams, therefore you have to change to kilogram by dividing it, the 28 gram, with 1,000. G is 9.81. Height is 4.6. You get 1.26 joules, which you can round it off to 1.3 joules. B is the answer. Question number 18. A sample of metal is subjected to a force which increases to a maximum value and then decreases back to zero. A force extension graph for the sample is shown. When the sample contracts, it follows the same force extension curve as when it was being stretched. What is the behavior of a metal between X and Y? Okay, don't worry about that because they told you that when it contracts, it follows, right? When it was being stretched, there is no permanent deformation. When there is no permanent deformation, cancel to plastic. There is, oh, okay, not plastic. Yes, it is not plastic. It's definitely not plastic. You see plastic, this is no. Not plastic, yes. Not plastic, yes. Not elastic, this is not possible because it is elastic because it will go back to zero, right? So not elastic, this is not the answer. Could you see I cancel all the choices here and left C. C is the answer. Question number 19. Two wires, P and Q, made of the same material, are stretched with an increasing force. A graph is plotted of the variation with force of the extension of each wire. The wires have the same original length but different diameters. What is the ratio of the diameter of wire Q to the diameter of wire P? When they say that, okay, this is about extension, this is about the force, and they say that this wire has the same original length, different diameters, and make of the same material. This is very important. Same material means the Young modulus will be the same, right? So equation of Young modulus, stress over strain. Stress is force over area, whereas strain is extension over original length. So Young modulus is equal to FL over AX. Now I find the Young modulus for P first. For P, Y of P is equal to F of P is force of P is 2 Newton. Same original length, so length will be the same. Over, oh, diameter. This is surface area, cross-sectional area. So you have to imagine that for a wire, the cross-sectional area is the area of a circle. So A is equal to pi r square. But the problem with us is that there is no apparatus in the laboratory that could be used to measure the radius of the wire. We can only use a micrometer to measure the diameter of the wire. But diameter over 2 is equal to radius. So you sub into the equation, you get pi d over 2, the whole thing, you square it, you get A is equal to pi d squared over 4. Remember, this is super duper important. Therefore, 2L pi diameter of the, diameter of P dP square over 4. Extension of P is 3 mm. Not going to change 3 mm. Then I'm going to put it as 3 times 10 to the power negative 3 because I want to change it to meter. I put this, okay, P. And for Q, the Young modulus of Q would be, length of Q would be or same original length, but the force of Q is 1. Force of Q is 2. 2L, 1 is the extension, sorry. Pi dq squared over 4. The extension of Q is 1 times 10 to the power negative 3. Since they are made of the same material, the Young modulus must be the same. Young modulus of P is equal to Young modulus of Q, so I put 2L. Pi dp squared over 4 times 3 times 10 to the power negative 3 is equal to 2L. Pi dq squared, diameter of Q, you square it, times 4, 1 times 10 to the power negative 3. Cancel, 2L, 2L, pi over 4, pi over 4. So you do your cross multiplication, put dq, cross multiply dq square over dp square. You get 3 times 10 to the power negative 3 over 1 times 10 to the power negative 3. 10 to the power negative 3 just cancel off, 3 over 1. Therefore, dq over dp is equal to square root of 3. C is the answer. Question number 20, an extension force graph for a spring is shown. What is the spring constant of the spring? Now, using Hooke's law, F equals Kx. Spring constant is K. It is equal to F over X. F is 6 Newton. Here, 6 Newton. Extension is 15 cm, but cm I need to convert to meter because I look at the unit of the spring constant, which is per meter. So I times 10 to, or I divide 100. So I will get, this is meter. So I will get 40 Newton per meter. D is the answer. Question number 21. A man stands stationary in front of a swing. A child sits and swings. The child blows a whistle that emits a sound at a constant frequency. The man observes the frequency of the sound when the swing is at position X, Y, and Z. When will the man hear the highest frequency? The highest frequency can be heard, this is Doppler effect, when the child with the whistle, right, is going towards the man. Right? So when the swing is at X, this man will only hear the frequency of the whistle. That is the real frequency of the whistle. It won't hear the highest this man would not hear the highest frequency. It will hear the constant frequency. A cannot be the answer. B, when the swing is at Y and moving away. No, moving away, you could listen to the frequency decreasing of the frequency. C is the answer. And at Z, this man could listen to the same frequency emitted by the whistle. Number 22, a loudspeaker is playing music in a room. The door to the room is open and has a width of 0.8 meter. Sound waves of many different frequencies pass through the doorway and diffract. Speed of sound is 340 meters per second. Which frequency of sound wave diffracts the most as it passes through the doorway? Now I'm going to use V equal to F lambda, the equation of wave speed. For the maximum diffraction to occur, diffracts the most, right? The wavelength of the wave must be equivalent to the gap of the opening. So that is why the wavelength must be 0.8. Now I sub in 340 is equal to F times 0.8. F is equal to 340 divided by 0.8, and you get 425 hertz, or you round it off to become 4.3 times 10 to the power 2 hertz. This is D. Question 23. A stationary sound wave is set up between a loudspeaker and a wall. A microphone is connected to a cathode ray oscilloscope, CRO, and is moved along a line directly between the loudspeaker and the wall. Amplitude of the trace on the CRO rises to a maximum at position X, falls to a minimum, and then rises once again to a maximum at position Y. The distance between X and Y is 33 cm. The speed of the sound in air is 330 meters per second. Which diagram could represent the CRO trace of the sound received at X? Okay, so I'm going to draw out the wave first using the information given here. So I'm going to draw out the wave here. So they told us that, I'm going to draw out the wave first. They told this is a wave. Okay, so the question, oh, sorry. Okay, this is the wave. The question did mention that rises to a maximum value. I would say this is X, maximum value, and then fall to a minimum and rises again to a maximum value, which is Y here. So the distance between X to Y is 33 cm, right? So when they say distance, the x-axis must be distance. Now, but one wavelength is from peak to the other peak, which is here. So this is called one wavelength. So I need extra 33 cm to give me a wavelength because that is only the half of the wavelength. 33 cm is the half of the wavelength, right? So one wavelength is 66 cm, 33 plus 33. Now I use V equal to F lambda to find my frequency first. V is the speed of the wave, 330 meters per second, but the wavelength is in cm. 66 cm is the wavelength. So I'm going to change that cm, 66 divided by 100 to change it to meter. So the frequency is 66 cm is the wavelength, 0.66. Frequency is 500 hertz. From the frequency, I can find period, which is equal to 1 over frequency, 1 over 500, which is equal to 0.002 second or 2 millisecond. Now, yeah, to see the number of the boxes, how many cm needed to form a wavelength, I would use this relationship. Period is equal to the number of cm, how many cm to form one period, right? Times the time base. So since the time base is in millisecond, I change my period to 2 millisecond. 2 millisecond is equal to number of cm that I need times the time base, which is 0.5 millisecond per cm. Could you see that millisecond and millisecond can be cancelled off? That is why this is 2 cm divided by 0.5 and I got 4 cm. So 4 cm to form one complete oscillation. So 4 cm, 1, 2, 3, 4. 4 cm to form one complete oscillation. That is why B is the answer. Question number 24. Polarization is associated with a certain waves. Which waves cannot be polarized? The only wave that cannot be polarized is sound wave, right? That is why the answer is B. 25, a guitar string is plucked. Which statement describes the resulting waves? When the guitar string is plucked, this is transverse wave. And you can listen to the beautiful sound of the guitar. That is longitudinal wave. Therefore, the answer is C. 26, a diffraction grating with n lines per meter is used to diffract light of various wavelengths, lambda. The graph shows the relationship between the diffraction angle theta and lambda for different wavelengths in the nth order interference pattern. What is the gradient of the graph? Now, I have to do the relationship here. I have to form an equation first, then I see, yeah, what is the relationship? For diffraction grating, d sine theta m, or theta n in this case, I'll just put sine theta, is equal to n lambda. And there's a relationship between grating spacing and number of lines per meter. Grating spacing is 1 over number of lines per meter. Sine theta is equal to n lambda. Just put sine theta as the subject. Sine theta is equal to n lambda. So this is your y-axis. This is your x-axis. The gradient would be nm, which is 8. Question number 27. A stationary sound wave is formed in the air column inside a tube that is open at both ends. The stationary wave has 3 nodes. How many antinodes does it have? I would draw, this is tube open at both ends. Bear in mind, the rules are the open ends must be antinodes. So since there are 3 nodes, I would draw 1, 2, and 3. And then the other wave would be using different color here, maybe orange color to show, okay, 1. Okay, I'm very sorry that my wave is a little bit ugly here. Right, go back. So this is 1, 2, 3 nodes. Could you see that? So how many antinodes here? I have 1, 2, 3, and 4. There are 4 antinodes. D is the answer. Question number 28. Interference fringes of separation X are observed on the screen at a distance 1 meter from a double slit that is illuminated by yellow light of wavelength 600 nanometer. At which distance from the double slit would interference fringes of the same separation X be observed when using blue light of wavelength 400 nanometer? So for interference, I'm using this equation. Lambda is equal to AX over D. Lambda represents the wavelength, A represents the double slit separation, X represents the fringes separation, and D represents the distance from the slit to the screen. Now, I sub in yellow light, 600 nanometer. A, they didn't say that A, so I just put A. The fringes separation is X over D is 1 meter. So I have AX is equal to 600 nanometer. I form it as equation 1. And the second situation is that using the same equation, but now the wavelength has already changed to 400 nanometer. And then same separation, same A, same X, because you use back the same double slit. And D, I have to find. So from 1, I have AX is equal to 600 nanometer. I'll just sub into this equation. So 400 nanometer, AX is equal to 600 nanometer divided by D. D is equal to 600 nanometer divided by 400 nanometer. Cancel the nanometer. You will get 1.5. So D is the answer. Cancel the nano. So you will get 1.5 meter. So because this is 1 meter. Okay. So 29, what is the definition of potential difference across a component? Definition of potential difference is the work done or the energy to move a charge from one point to the other point. Right? Energy transferred per unit charge is the answer, A. 30, the diagram shows a cell of negligible internal resistance connected to a switch and two resistors of resistances R and 2R. The circuit also contains two ammeter, X and Y, and the reading on X is 4 ampere when the switch is open. What are the readings on X and Y after the switch is closed? Now, when the switch is open, the ammeter reading is 4 ampere. When the switch is closed, what is the reading on X, right? So the reading on X would be different when the switch is closed because the total resistance will decrease. So the current on register by X would increase. So I will find the total resistance first between these two. 1 over R plus 1 over 2R, then you invert it. The total R supposed to be, this is times 2 times 2, 2 plus 1 over 2R, so invert it. R total is equal to 3 over 2R, invert it. So R total is equal to 2R over 3. Oh, now I am going to find my IX. I know that IX, okay, I am going to use Ohm's law. When the switch is open, right, I'm going to find my potential difference. Yeah, this is a total potential difference, total potential difference. When the switch is open, when switch is open, so I'm using Ohm's law. V total is equal to I times R because there's no current passing through 2R. So V total would be 4 times R. So this is equal to 4R. And the question did not mention that they changed the cell. That is why still the same cell is being used. Now I want to find the current at X. So since the switch is closed, I use Ohm's law as well. V total is equal to IX over R total. V total is 4R. IX, R total is 2R over 3. Now, IX, R and R can be cancelled off. IX would be 4 times 3 divided by 2. So this is 6 ampere. That is IX. So 6 ampere for IX. Whereas for IY, I'm going to use the Ohm's law as well. V total is equal to IY times RY. The one that is connected to RY. So V total is 4R, IY times 2R. So R and R cancel off, IY is equal to 2 ampere. So the answer is C. Question 31. The IV characteristics of 4 components A, B, C, and D are shown. Which component has the greatest resistance when the potential difference across it is V1? So since they have the graph given here, actually the resistance is being calculated from the ratio of the current, of the voltage to current. But now because the values are not given, that is why for curve, I'm just going to draw tangent. And hey, you have to bear in mind, this is current over voltage, right? Current, R value is equal to voltage over current. But this is current over voltage. You have to bear in mind. So when you find current over voltage, you are finding 1 over R value, invert of R, right? So invert of R, if the line or the curve is if the tangent line that I'm going to draw is least, yeah, steepness, right? So that will give you the greatest R. Okay, so this one is a straight line. So this one is a tangent that I'm going to draw. So I could see that the tangent of C is steeper as compared to the tangent of D. So the tangent of D is less steep as compared to A, B, and C. Less steep meaning to say that 1 over R value is the smallest. That is why R, you divide 1 over R is the smallest, meaning to say that R is the largest value. D is the answer. Question number 32, a cylindrical wire has a cross-sectional area A and number density of free electrons N. The wire has current I and the free electrons have average drift speed V. A second cylindrical wire has a cross-sectional area 0.5 A and the number of density of the free electrons 2N. And this wire, the free electrons have average drift speed 2V. What is the current in the second wire? Now I have to form two simultaneous equation again. I is equal to NA V. And what is the free electron? I just put E. So this is my first equation. Now I have to find I2, the second wire. N is 2N, A is 0.5 A, and V is 2V times E. Second equation, so I'm using the second equation, divide the first equation. There's a lot of simultaneous equation in this paper, don't you think so? Right, so I have 2N AVE over NAVE. NAVE just cancel off. That is why the current in the second wire is 2 times the current in the first wire. C is the answer. Number 33, an electric current is formed by moving carriers, charge carriers. What is not possible charge on a charge carrier? Bear in mind, the fundamental charge is 1.6 times 10 to the power negative 19 coulomb. If I get all the choices here must be possible charge, right? Must be able to divide 1.6 times 10 to the power negative 19 coulomb without giving any decimal point, right? So 4.8, right? I get 3 times the fundamental of charge, which is 1.6 times 10 to the power negative 19. 2.4. I get 1.5. If you get 1.5, this is not possible. You're supposed to divide it without any decimal point. So 1.6, I get 1 charge. And 3.2, I get 2 times the fundamental of charge. So B is not possible charge. Number 34, which description of Kirchhoff's first law? First law is about junction rule. It is about the principle of conservation of charge, right? A is the answer. Number 35, two resistors of resistances R and R are connected in parallel. The value of R is less than the value of R. Which statement about the combined resistance of the two resistors is correct? If you have a problem, just put any value for R and we see. This is 5 ohm. Let's say this is 5 ohm. This is 20 ohm. Since they are connected in parallel, I find the R total, which is 1 over 5 plus 1 over 20. And then you invert it. Get a value. So it doesn't hurt to get that, right? So you don't have to think too much when you sub in the value. So 1 divided by answer, I get 4 ohm. 4 ohm for the total resistance is definitely lesser than the internal resistance itself. That is why D is the answer. Because my internal resistance is 5 ohm, I put it as 5 ohm. You can put it with any other numbers, up to you. Now, question number 36. The diagram shows 4 identical resistors connected in the circuit. Which resistor dissipates the most power? I am using P equals to I square R. Identical resistors, that means the resistances must be the same, right? So I would say here, the current split. That is why the most current pass through A will dissipate the most power. A is the answer. Question number 37. Nuclide X with a proton number Z undergoes beta plus decay to form nuclide Y. The decay may be represented by the equation X is equal to Y plus beta plus W. What is the proton number of Y and which particle is represented by the symbol W? So proton number of Y must be deducted by 1 because this is plus 1. So you have to make sure the left-hand side proton number is equal to the right-hand side proton number, right? So that is why it has to be, for Y, it has to be Z minus 1 in order to get Z. Z minus 1 plus 1, you get Z. So that is why it's either A or B. So since this is a beta plus, the energy, the particle represented by W must be neutrino. B is the answer. Number 38, which fundamental particles form a hadron? Hadrons, proton and neutrons, quarks is the answer. 39. The unstable nuclide 21884AX decays through a sequence of emission of alpha and beta negative particles to form the stable nuclide of 210Y83. Right. How many alpha and beta negative particles are emitted during this decay process? You know how I do it? I just put 21884 first, X. Yeah. Give me 21083Y. Now, I take 218 minus 210. I get 8. So I need to form 8 nuclear numbers on the right-hand side. So I minus, plus alpha is 42He. So how to get 8 on the nuclear number? I need to emit 2 alpha particles. 2 alpha particles could be B or C. But hey, you look at the proton number. This is 84. Right? This is 83 plus 4, right? So you have to deduct something. 84, yeah, you need to get back 84. So this is 83 plus 4, that gives you 87. 87, you need to deduct 3. 0, negative 1, beta, negative, in order for your proton numbers to be balanced. C is the answer. And the last question, which statement about the radioactive decay is correct? Now, neutrinos are always emitted during alpha decay. That is not always. Always is the word that's very dangerous. B, the alpha particles emitted from the radioactive sample have a continuous range of kinetic energies. That is not. That is beta particles, right? C, the beta negative particles emitted from a radioactive sample have a continuous range of kinetic energies? Yes. D, the proton number of a nucleus decreases by 4 when it undergoes alpha decay. How can a proton number decreases by 4? It is a nucleon number. Proton number decreases by 2, not 4. So that's the end of the discussion of May-June 2024, paper 14. If you have any hesitation, if you have any idea, please feel free to comment below. Thank you very much for watching and see you in my next video. Bye.